Hi, Assalamualaikum. My name is Muhammad Syahmi and I'm from Group 110 Engineering Team Project. My group is under supervision of Dr. Aliyu Adebayo Sulaiman. So, our project is Aqua Security, a resilient emergency water supply system for campus infrastructure. Are all my teammates. As you can see, there is a problem statement, SDGs, proposed solutions, and also benefit.
Our purpose statement is, at University Technology Petronas, campus operation rely heavily on continuous supply of treated water to support academic buildings, laboratories, accommodation and cafeterias. Although the supply is generally stable and reliable, unexpected circumstances such as pipe failures, scheduled maintenance or extreme weather condition may disrupt the system and affect campus operation. A nearby raw water reservoir presents a potential contingency water resource during such emergency. However, the raw water normally contains high turbidity, suspended solids, organic matter and microbial contaminants. Therefore, it is unsuitable for direct consumption or usage. Hence, there is a need to design an integrated emergency supply water system that utilizes the raw water reservoir, incorporating a proper piping network and filtration unit to ensure safe and stable water distribution. As you can see in figure 1, we have collect many evidence. Recently, there were recorded water supply disruption in UTP. So to address this issue, we identified a possible water reservoir near the UTP. This reservoir can serve as an emergency backup water source during this supply disruption. For our SDG that relate to us is, we have SDG 6, which is clean water and sanitation. Our project aims to improve water quality, enhance freshwater accessibility, and ensure efficient water use during emergency. Second is SDG 11, sustainable cities and communities. By implementing a backup emergency water supply system, we enhance campus resilience and promote sustainable water management practices.
I'm going to explain the flowchart. So basically, this flowchart illustrates the process flow for a water supply system. It begins with the water reservoir, which store the untreated water. From there, the water is directed to the water filter, where it undergoes purification to remove any contaminants. Once the water is filtered, it flows into the water storage tank, where it is stored until it is needed. So next step involves the centrifugal pump, which moves the water from the storage tank and ensure a continuous flow throughout the system. A check valve is included in the flow to prevent any backflow, ensuring that water only moves in the correct direction. Following this, a gate valve allows for the regulation of water flow, giving operators control over when to open or close the flow depending on demand. The water then travels to the pipe section, which connects all the components and continues its path toward the vent valve. The vent valve releases any excess air or pressure in the system to maintain smooth operation. Finally, the water reaches the outlet, completing the cycle and making it available for use. This process runs continuously to provide a reliable and efficient water supply.
So now we'll be moving on to the second part of our proposed solution, which is the purification unit. So in this project, we are using the raw water resource, which is inside the UTP, which is classified to the surface water reservoir for non-potable use. So this purification unit will start from the screening process, which removes large debris, okay, by using the stainless steel sieve, and it will follow by the filtration unit, which remove more fine suspended solid, okay, by using the gravel, fine sand, also activated carbon, or this combination of these materials. And it will follow by the disinfection process by using chlorine solution to kill the bacteria and to avoid the growth of microorganisms. And lastly, it will store this treated water in the storage tank to ensure the more stable water supply. Because as you know, this treatment process is actually taking time and it is not a rapid process. But overall, this current design of the treatment unit is actually serve as a conceptual solution only. So the actual performance is need to be further validation through laboratory analysis to uh, accurately assess our water quality parameters and to optimize the treatment process. This including to determine the appropriate filtration rates, chlorine dosage, and also the overall system efficiency. Thank you.
Our solution offers several unique values that make it highly practical and impactful. So the first one is it is a dual function infrastructure, meaning it only operates during emergencies and integrates seamlessly with the existing water system. So no major overhaul is needed. Second, we utilize the existing raw water reservoir, which we transform it into a strategic emergency asset. So this reduces dependency on external solutions like water tankers, which are often slow and limited. The third one is the system is modular and scalable, which allows itself to serve small areas or expand to the entire campus. Additionally, it features a rapid activation mechanism, which enables the system to operate within hours during disruptions. Finally, our design integrates both hydraulic and filtration engineering, ensuring not just water delivery but also safe and reliable water quality. So, with these features, it makes our solution resilient, efficient, and ready for real world implementation.
So, to wrap all this up, Aqua Security delivers reliable emergency water storage. For long-term benefits, it includes community engagement and environmental improvements. And for the future plans, it will focus on expanding initiatives. And lastly, my call to action is we must support local water conservation. Thank you.